Function. A function is a set of statements organized together to perform a specific task. Functions are very useful when the block of statements must be executed again and again. R comes with many functions that you can use to do sophisticated tasks like random sampling. For example, you can round a number with a round function or calculate its factorial with a factorial function. Using the function is very simple. You just have to write the name of the function and then the data you want the function to operate on in the parentheses. For example, round, the name of the function, and 3.1415 is the data written in the parentheses on which the function will work upon. Similarly, factorial, the name of the function, and 3, the value of the function written in the parentheses the function will work upon. The data that you pass into the function is called as a function's argument. For example, 3 is the factorial function's argument. Now, the argument can be of 3 types. It can be raw data, it can be an R object, or even the result of another R function. Please note, if another R function is passed as an argument of the function, then R will work from the innermost function to the outermost, as you can see in the figure. Now let's see how we can use the function to simulate a roll of the die. Now in order to simulate the roll of a die, we will use R's sample function. Sample function takes 2 arguments, a vector named x and a number named size. Sample will return size elements from the vector. For example, sample, the name of the function, x equal to a vector from 1 to 4, comma, size equal to 2. This function will return any 2 random numbers from the vector x. Now let's use the sample function to roll a die. Set x to die and sample one element from it. You will get a new number each time you roll it. Try it yourself. Please note that many R functions come with multiple arguments. You can give a function as many arguments as you like, as long as you separate each argument with a comma. You may also notice that every argument in R function has a name. So you can specify which data should be assigned to which argument by setting a name equal to data, as we saw in the sample function. Naming the argument becomes important because as you begin to pass on multiple arguments to the same function, naming the arguments helps in avoiding passing the wrong data to the wrong argument. However, using names is optional. Now, what will happen if you wrongly use the argument names? Well, R will simply throw an error as shown in the code below. Now, if you are not sure which names to use with a function, you can find out with the args function. Place the name of the function in the parentheses of args function and you will able to get the argument names that are contained in the function. For example, argsRound will give you the name of the two arguments used in round function. Now did you notice one thing? That the digits arguments in the round function is already set to 0. Now this is quite frequent because in many of the R function you will notice that optional argument like digits is set to default value. In this case the default value is 0. Well, you can always change the default value by setting the new value to an optional argument. For example, if I change the default value from 0 to 2, then the round function will give me the different result as below. Now if you do not write out the names of your arguments, then R will match your values to the arguments in your function by order. For example, in the following code, the first value die will be matched to the first argument of the sample, which is named x. The next value 1 will be matched to the next argument, which is size. Now what will happen if the argument's order is interchanged? Now as a result, if the argument order is interchanged, then the values may get passed to the wrong argument. R will always match a value to its argument name, no matter where it appears in the order of arguments. Now let's look closely at this sample function. Now what I am doing here is that I am using the sample function, but I am putting size equal to 2. That means I am simulating the pair of dice. And so if I execute this function, then it will give me two numbers. So these two numbers are equivalent to the two values from each pair of dice, right? So it will give me two numbers, one for each die. Now if I run this sample function again and again, let me show you that. So I'm running this sample function several times. Now can you observe one thing here? This sample function is acting funny. And what is the funny part about it is that it is giving me two separate numbers, two different numbers. That means you will notice that the second die never has the same value as the first die. Now which means that you will never going to roll the pair of 2s or pair of 4s. So what is the issue here? What is going on? Well, the answer to this question lies in how sample function does the sampling. Now there are two ways you can do the sampling. First way is sampling without replacement, and the second way is sampling with replacement. So two ways: sampling without replacement and sampling with replacement. Now let's see these two methods closely. Let's first talk about sample without replacement. Now imagine that I've unfolded the die. That means there are 6 numbers. Each number represents a particular face, the number on a particular face of a die. And I'm putting these 6 numbers in a jar. So this becomes my population. Okay, so I put in these 6 numbers in the jar, and now what I'm doing here is that I'm going to select one random number out of it. Let's say I've selected number 3. So in sample 1, I've selected one random number, and that one number is number 3. Now I'm not going to put this number 3 back into the jar again. Okay, I'm going to put this 3 number aside. I'm not going to put this number 3 back into the jar again. So when I go and draw the second number, remember we are rolling the pair of die. We are rolling the pair of dice. That means we want 2 numbers, one from each die. So I got number 3 from first die. Now I am going to select the second number from the population, but this time I will not going to have number 3 as a part of the population, because I am not going to replace number 3 back into the jar, right? So I will be getting any number from number 1 to 6 except number 3 as my second sample. right? And that's what I got. For example, I got number 1. So now you can see that why sample is giving us two separate numbers. Why the sample function is giving us two separate numbers? Because sample function is using sample without replacement method. Whatever the first number the sample selected, the sample function is not putting that number back into the jar. And that's why that number is no more there to be selected. So I have two separate numbers now. And that's why I will not going to generate the pair of 3s or the pair of 2s. Now, one side effect of this sample without replacement is that each draw now depends on the draw that comes before it, right? So the second draw, now the outcome of the second draw depends on the outcome of the first draw. If I select number 3 on the first draw, then outcome of the second draw, I would know that I will not be getting the number 3 again in the second draw. So in a way, the outcome of the second draw now depends on the outcome of the first draw. But in real world, this should not be the case, right? The outcome of each die should be independent on the outcome of other die. When you roll the dice, the outcome of each die should be independent of each other. So if first die comes with 3, then it should not prevent the second die from coming up with the 3 again. That's how the situation should be in real world. The two dice should be independent of each other, and that independence can be generated if we do sample with replacement. Now what is sample with replacement? As you can see here, in the first sample I've drawn 3, but now this time I'm putting 3 back into the sample again. I'm putting number 3 back into the jar again. So now number 3 for my second draw becomes the part of the population. So when I go and draw the second sample, I have equal likelihood of selecting number 3 again, right? And this time it so happens that my sample 2 also the number 3, and I am now able to generate the pair of 3s, which I was not able to generate by using sample without replacement. Now if you use the sample with replacement method, then both the die are in the outcome of both the dice are independent of each other. That means if sample 1 number 3 is generated, then I have an equal chance of number 3 being generated in sample 2 as well. And that's why in this case, sample with replacement, I can able to generate pair of 3s, I can able to generate pair of 2s, I can able to generate pair of 4s. Now let's see how we can able to generate the sample with replacement in R. Let's go to the R code. Now let's check how we can generate the sample with replacement behavior of the sample function. Now before that, let's use args function to check the arguments of the sample function. Now you can see that these are the arguments of sample function. We saw x, we saw size, but look at here, replace equal to false. So default value of replace is false. That means by default the sample function is giving us sample without replacement method, right? And this probability equal to null, this probability is nothing but the probability of selecting each number. In this case, the null probability means each number has an equal probability of getting selected. So we are going to see this probability argument in the later course, but let's focus our attention on this replace equal to false flag. Now if I use sample function die comma size equal to 2 because I want to roll the pair of dice, and replace if I use true flag instead of false. Now I am using true flag for the replace. That means I am using sample with replacement method. replace equal to true, that means I am telling a sample function use sample with replacement method. Now let's check what we can get. Here we go. Now can you see? I can able to generate the pair of 5s. Now can you see that I have generated the pair of 5s? Well, that can be possible because now the argument replace equal to true causes the sample function to sample with replacement. So when sample uses replacement, it draws the value from the jar, it records the value, and then it puts the value back into the jar. So in other words, sample replaces each value after each draw. It replaces the 5 after the first draw, and that's why 5 is now getting available to be selected in the second draw, and that's why it gave me the pair of 5s. So if I run the sample function again, you could able to generate second pair of numbers. Have a look at it. We could now able to generate the pair of 3s. That's how the sample with replacement works. I hope you understood the difference between sample without replacement and sample with replacement. Both these concepts are very important when we generate the simulations and use those simulations to check our results. We saw how we can use the sample function for simulating the result of rolling a pair of dice. Now if I want to add up the dice, I can simply feed the result of a sample function straight into the sum function. So let me create the die object, and let me create another object called dice, and I am simply feeding the result of the sample function to the dice. Place equal to true, and now I am using the sum function to sum the pair of dice. So here we go. I can now able to sum the pair of dice, and which number it has added, I can simply call dice to see the numbers which have been added. So these are the two numbers that is being added by the sum function. Now what would happen if I call the dice multiple times, right? Would R generate a new pair of dice values each time? Let's try it out. So I'm calling dice multiple times. Sorry. Look what is happening. Each time I call dice, R is simply showing me the result that it has generated in the first instance when I use the dice object. That means every time when I call dice, R won't rerun the sample function to create a new roll of the dice, right? And because R won't able to rerun the sample function, I am getting the same result again and again, the same pair of dice again and again. But this is not a convenient way. This is not what we want, right? What we would want is that we would want to have an object that can re-roll the dice whenever we call it, right? We simply have to call that object, and that object will re-roll the dice and give us the two numbers. And every time we call that object, every time the output should be different than the previous output. That arrangement, that is what we want. And that arrangement we can do with the help of writing our own R functions. Now let's see how we can write down our own R function. Now let's quickly recap the R code that we have written to simulate rolling a pair of dice. We started by creating an object called die. Then we rolled the die with the help of a sample function. Remember, we use replace equal to true. We use a sample with replacement. And then we add up the dice using the sum function. Now we saw that if we want to re-roll the pair of dice, then every time we want to run the sample function again. That means what I have to do, I have to retype this entire code into the console every time I want to re-roll the dice. But this is a very awkward way to work with the code. Now it would be very easier to use the code if somehow I can able to wrap it up into its own function. And that is what exactly we are going to see in the next slide. So we are going to write a function called roll, and that function we can use to roll the virtual dice. And when we finish writing the roll function, it would work like this. Each time when we call the roll function, R will return the sum of the rolling two dice. Every function in R has three basic parts. It has a name, the body of the code, and the set of arguments. In order to make the own function, we need to replicate these parts and store them in an R object. Now to create the function, we need to write the name of the function. My function is the name of the function, followed by a function construct, and followed it will be the pair of braces. Function construct will build a function out of whatever R code we place between the braces. Now let's see how the roll function will look like. We have the function name called roll, followed by a function construct, then the parenthesis in which you can write the function arguments, you can input the function arguments, followed by the braces, and within the braces you will have the function body, which is nothing but the code that you want function to work upon. Remember, each function will give you the output. In this case, the sum of the dice will be the output for the roll function. The output of a function is saved in an R object. Now if we want to call the function, then we have to simply write the name of the object followed by parenthesis. Now you can think of these parentheses as a trigger that causes R to run the function. Now let's construct this function in our console. Name of the function, followed by function construct, and braces. It is a good practice to indent the code that you are writing within the braces. So I am using die as an object, then I'm creating another object called dice, in which I will be feeding in the output from the sample function. Is equal to true, and finally I am going to sum up the pair of dice being generated by sample. So this will be my output. The sum will be my output of the function, and finally don't forget to close the braces. So this is my function body. So this is my function body, and if I want to call the function, I will have to simply call the name of the function followed by parenthesis. Now let's check whether we can generate the sum. So here we go, we can able to generate the sum of the pair of tiles being generated by sample function. So this is how we can create our own function in R. Now this roll function doesn't have any argument in it. Now let's see how we can able to pass on the arguments to our own function. So for that I am creating roll2 object, and now I am going to pass on die as an argument to this function. Opening brace, opening brace, then ties object as we have done in the last function, replace equal to true. Rest of the code will remain the same. Only change that I have done here is that I have removed the dice. I have removed this die object from the body of the function, and I have put in die as an argument of this function, right? Enter. Now let's see what roll2 gives us. Here we go. It has given us the same output as the previous function, but in this case we have pass on die as an argument to the function. Now remember, you can pass on multiple arguments to the function provided you separate the arguments out with the help of comma. Now if you want to see the body of the function, what you can do, you can simply write the name of the object without parenthesis. If I write the name of the object without parenthesis, then you can see the body of the function. Roll2 without parenthesis, you can also see the body of the function. So to sum up, we saw how we can able to write our own R function. Remember, each R function will have three parts to it. It will have a name, it will have the argument, and it will have the body of the function. The body of the functions rests between the braces, and once you create the function, remember that each function is considered as an R object. As you go on writing your own R functions, you will realize that writing your own R functions will give you a lot of flexibility in doing your analysis. So far, we have been writing the R code in the console. We created our own function roll2, and while creating this function, all the code that goes inside the function, everything we have written in the console. But unfortunately, the code that you write in the console, you can't save it. So if I close this R session, and if I open the R session again, maybe tomorrow, then I will have to write the entire roll2 function again. So that is the most inefficient way of writing the code. So we need some mean of saving the draft copy of our code. We can do that with the help of RScript. If you write a code in RScript, then RScript will simply save the draft of your code. RScript is a simple text file in which you write the R code. You can open the RScript by going to the file, new file, and RScript. As you can see, RStudio will then open the fresh script above the console pane. Now I strongly encourage you to write and edit all the R code in the script before we run it in the console. Now this habit will create a reproducible record of your work. So when you are finished for the day, then you can save that script, and next day when you want to work, you can simply open the file of that script. So scripts are very handy for editing and proofreading the code, and they also make a copy of your work to share with others. To save a script, click the scripts pane, go to the file and save as. It will save the copy of the scripts in your local folder. Now let me show you how the code in the script looks like. Let me create the role2 function using the R script. There are two buttons that you can see, the run button and the source button. R will run whichever line of code your cursor is on with the help of run button. So if I want to execute this line of code, then I will put my cursor on this line and I will simply click on the run button, and it will execute the roll function and it will give the result in the console. You can also execute the entire piece of code that you have written in the R script with the help of source button. So if I want to execute the entire code in one go, I will use the source button. So we saw how we can able to use the R script to save the draft copy of the code. R scripts are very handy, especially when you want to write multiple lines of code.